In this video, we're going to look at addition reactions. Addition reactions are the first of the reactions that were responsible for knowing that organic chemicals or organic reactions that we must know the reactants and be able to predict the products. So we need to know these reactions kind of inside and out, and we see a number of those reactions in chapter 10. So addition reactions are that first one that we're going to see, and essentially what addition reactions occur for alkenes and alkynes, because what it does is it breaks the double or triple bond. So if it is an alkene or an alkyne, not aromatics, but an alkene or an alkyne, it can undergo an addition reaction. And so our first one that we're going to look at is the addition of bromine to an ethene. So we've got the ethene, and we're going to add bromine to it. And essentially what you're doing is you're breaking the double bond of the ethene, and you're going to add a bromine to each. So my bromine molecule is a symmetrical molecule. It's got two bromine atoms, and my ethene has got this double bond that's here. Well, what happens is the double bond gets broken, and a bromine is going to be added to each of those carbons. So over here, I've got a bromine on each of the carbons, and now I'm down to a single bond. So ethene plus bromine makes 1,2-dibromoethane. Well, that's essentially what happens with addition reactions. And so our first addition reaction that we're going to look at and do together is going to be adding chlorine to butene. So chlorine is, again, a diatomic element. So it's this nice symmetrical two-sided, two sides are equal molecule that we're going to add to but1-ene. So my but1-ene is going to have a double bond on the first carbon, and it stretches the second carbon. So what's going to happen is this double bond here is going to get broken, and each of these carbons is going to get a chlorine attached to it. So I'm going to get a CH2, CH, CH2, CH3, but now on the first carbon, it gets a chlorine, and on the second carbon, it gets the other chlorine, and so I've got but1-ene plus chlorine makes 1,2-dichlorobutane. And so that's how you can do an addition reaction, and it's just really quite straightforward. I see that there's an alkene or an alkyne, and I'm going to break that multiple bond, the double or triple bond, and I'm going to add something to each of the two carbons of the double or triple bond. Now, both of our examples so far have had this symmetrical molecule, and I've mentioned that, and it probably doesn't seem obvious why that's the case, but the reason I want you to see that is that in our next example, we're not going to have a symmetrical molecule. In this case, we're going to have a propene, and it's going to have a hydrogen bromide added to it. Now, hydrogen bromide is not symmetrical. It's got a hydrogen atom as well as a bromine atom, and they're both going to get added to the carbons where the double bond has occurred, because we're going to, again, break this double bond, and something's going to get added to each of the two carbons. But in this case, I could have a hydrogen bond to this carbon and then a bromine to this, or my bromine will get attached here and my hydrogen here. So if this happens, I'm going to get CH3, CH2, CH3, sorry, that's wrong. I'm going to get CHBr. And so this is going to be a 2-bromopropane. And it will, if this occurs, then I'm going to get the bromine on the first carbon. Oops, what am I doing here? Just making all sorts of mistakes. Sorry about that. So CH2, CH2, CH3. And so my hydrogen that gets stuck here, just I'm lumping it together. But in this case, I'm going to get a 1-bromopropane. And these two chemicals
have different structures and different names, but they have the same molecular formula. It'll be C3H, it would be 8, but 7Br, because one of them's a bromine now. So they've got the same molecular formula, but different structures and different names. They'll be slightly chemically different. And so we're creating isomers in this reaction. So you want to be aware of that. See, we've got these two isomers that are forming, and we'll do this example that's here, where they've got the reaction of hydrogen iodide with but1-ene. Name all the molecules. I'm going to let you pause the video here and see if you can do this on your own, and then I will complete the reaction. So pause. I'm assuming you're on pause now. So CH, so it's a but1-ene. So I've got my double bond on my first carbon, and sorry, that's a 3. And so this is going to be H2H. And I'm adding hydrogen iodide. Now my hydrogen can bond here and my iodine here, or you could reverse it. So I'm going to get hydrogen and iodine here, or iodine and hydrogen here. So we'll do this one first, where I get CH3, CHI, CH2, CH3, and this will be a 2-iodo-butane. And my other product is going to be CH2, my iodine's going to be here, CH2, CH3, or 2CH3. And so I get 1-iodo butane. In this up here, it says what the major products are. I'm never going to ask you what's the major and minor product. That's kind of beyond the scope of this course. So I just know that the 2 isomers are being produced and how to name them. Another kind of addition reaction is where you're adding hydrogen. And so this is very, this is exactly the same as when you were adding the halogens, but now what we're doing is we're just saturating it. So that's what they do when they get saturated fats. They get fat molecules that have a double or a triple bond, and then they react them with hydrogen, break the double or triple bond, and it saturates it. So it becomes like just an alkane.